So I just did one session. I recognize a couple of faces here of a session I just did. I will just do a quick recap, just for the people that weren't in the first session. But I'm not going to go through the same material, obviously. So we'll look at some of this stuff. We have some new things. I mean, if you're serious about mixed reality development, these are probably the things that you're going to be tested on, really, as in, as a developer. So we'll look at mixed reality toolkit, which is awesome. Some more gestures, which I promised in the first talk, voice commands, and how that more learn the design of voice commands and the design of spatial audio, and then we'll look at spatial mapping and testing. And I know we all, if we're developers here, we love testing, right? No? Oh, okay. Again, questions? I thought I brought bribery. So if you ask really good questions, you get Australian Tim Tams, right? And these are the special ones. This is the choc mint. And the chewy caramel, right? It's not just any Tim Tams. You don't ask questions, you don't get any Tim Tams. Okay? No.
When do we get to the bedroom?
That was the first talk.
It was. No.
See, the title is just, there's two. If you've never submitted for a conference before, there's two aims with the title. One is to get your talk in, right? Be interesting. The other is to get people in your room, be interesting, right? And that's it. It should also be descriptive of what you're doing. Are you asking why the title was there's holograms in my bedroom? Yeah. Because you can put them anywhere. You can use any room, anything, right?
So it was a trick.
It was a trick. I got you. So.
I have another question.
Yeah, sure.
Do I get the cookies?
When you ask a really good one. So, we'll just do a quick overview of essentially the 5 pillars we were talking about before. So we got gaze. It's not what your eyes are looking at, it's what your head is pointing at. Okay? We don't track eye movement, we track head movement. We have gestures, which is tap and bloom, right? There's only those two. Okay? We'll do a bit more with this in a minute. There's voice commands. Either you just say select, which just selects the things like tapping, or you can have see it, say it. So if you see a label on a button, you can say that while you're gazing at the app, and it'll trigger that command. Or you can do custom commands as well, which is what we did. We got some spheres we dropped and everything. Sound, audio, spatial audio is really important for the experience, because you remember, you don't control the environment with this, right? You want to blend in. You want to appear as if you are an extension of the actual reality, hence the term mixed reality. So your sounds have to be natural, they have to be convincing, they have to fit whatever it is your experience is, which they obviously didn't do in the first demo. If you weren't here, they were terrible, okay? We'll look at sound design as well a little bit later. And then spatial mapping, which is what makes HoloLens HoloLens. Without spatial mapping, there is no HoloLens. The 4 cameras on the front that builds a 3D model of your world that you're in, or of the environment, is key to the spatial mapping, to the HoloLens experience using spatial mapping.
I have a serious question.
Yes?
The objects, I didn't see them cast in the shadows.
Oh, on the ground or whatever. You can.
You can?
You can. You generally don't, because you don't know what other lighting sources there are.
So it doesn't know where the light sources
No.
are?
No.
Okay.
No, it's not that clever. But in Unity, you can put your own lighting source on things as if there was a light on it. Right, so you can do that. We're going to start with looking at Mixed Reality Toolkit, which used to be called the Holo Toolkit, so I will probably call it Holo Toolkit many times. Most of the documentation still says Holo Toolkit, but they changed the name because it's for all mixed reality devices, right? It's freely available on GitHub. There's a version for Unity, and there's a version for Visual Studio. Most likely you will use the Unity version. And I'll give you a bit of background on it. So there's 2 games for HoloLens. Again, I don't think it's a gaming device. It does gaming well, but it has a lot better applications than gaming. But these 2 games, Fragments and Young Conquer, are incredibly well made. They're some of the best users of mixed reality I've seen. And they were made as a showcase to sell the HoloLens. Right, they came out from the beginning. As soon as people could buy the HoloLens, there was Fragments, and Young Conquer came shortly after. They're built by a French studio called Sobo in Bordeaux. And they found out, so Fragments, a bit about what the game is, you're a memory detective, and you can see fragments of people's memory, hence the name. And you spatially map the room that you're in, and fragments of this boy's initially memory are shown wherever it can. Right, so it depends on what room you're in, it'll be a different experience every time. For example, the first level, there'll be a hole in the roof and rain comes in. That's a memory of the boy you're trying to find. Right, it's very, 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 very well made. It's incredibly convincing. They found out that in order for them to place things and have like characters like that come in and sit on your furniture, well, they need to be able to identify what a wall is, what a ceiling is, what a couch is, what a chair is. So they built a bunch of tooling around the spatial mapping, how logically to know two surfaces like this is a couch and so on. And this means that they could very easily identify where the ceilings, where the walls, where the beds, where all those things. They built a whole lot of other tools or scripts, and in the end, Microsoft decided to put it all out as open source, and it became the Holo Toolkit, which is now the Mixed Reality Toolkit. So it's very much a community effort. It's supported by Microsoft, but a lot of independent HoloLens developers, mixed reality developers, are supporting this, and as they find bugs, they'll update it. As there's new versions of APIs, they'll update it. It's very, very, very important if you decide to develop for HoloLens. They even have their own logo now. That's how serious it's become. But it gives you essentially these kind of categories of shortcuts and helps and scripts. It gives you input. So in the first talk, we were talking about gaze and voice and all those things. And this gives you scripts that manages all that for you. So it makes it much easier and much more elegant to implement gaze and gesture and voice. Sharing. We didn't talk about sharing. We're not going to talk about sharing today. But there's a sharing experience where you can have up to 8 HoloLenses see the same experience. It helps you with that as well, setting all that up. Spatial mapping. Scripts that allow, as we talked about, to identify what different things are, what's the walls, what the ceilings. Spatial understanding. Sorry, that's the spatial understanding. Spatial mapping as in displaying the spatial mapping and understanding and interacting with it. Spatial sound. Scripts to help plug spatial audio into your application. It's not difficult, but there's some helper scripts around it. There's not too much of it. UI controls, such as your cursors. You get free cursors because no one wants to build a cursor, really. That interacts and does things as you use it. A bunch of utilities, a whole ton of utilities of very nerdy scripts, and then some build automation tooling as well. So I just want to quickly show you what it looks like. And you go to GitHub and you download, the mixed reality Unity package. That's the file name, .unity package. And it's not very big. If you don't want the examples, it's about 10 meg or so. And it's a very common thing in Unity to use, import custom package. And there it is. I'll put it on the desktop as it is. And you open it, and it decompresses it, and it shows you a bunch of stuff that's in it. Now, I'm not going to import it because that takes a while, so I've already done that. So nothing to import. Gets you another menu in here. Now, if you've ever gone through any of the tutorials on Microsoft website, they tell you to go and change the camera to this and change the background to black and move it over, and all these tedious things you have to do every single time. Because Unity was not made for mixed reality development, but now it is used for it. Right? So there's a bunch of things you need to do, and you can just do it now with a click of a button. Configure, apply mixed reality project settings, such as make sure it's Universal Windows Platform, which is Windows 10 development. Enable XR, which is the VR type world. The 3D building, .NET scripting, all that stuff that you would otherwise have to hunt around and remember to do every single time. And you now get that for free. And with little helper boxes and everything as well. Close that. And it's the same with configuring the scene and the capabilities that you want to use. Very, very useful. But that's just the start, right? You just use that for 10 seconds when you start a new project. The real value is in all of the things. I'll just make this a little bit taller here. That are in the Holo Toolkit. So all this comes as assets in your project. And for example, if you wanted to do, say, input, we can go and there's scripts. There's all different kinds of scripts. For editors, for cursors, gamepads. If you want to look at the cursor script, there's a ton of animated cursor scripts, and there's some interfaces if you want to build your own to make sure they adhere to the HoloLens framework. Mesh code, I don't know how many there are. I would guess maybe 300 different scripts that you can use, and it's all managed and maintained for you through the GitHub repo. It's invaluable as a developer. Like, it takes a lot of time off the plumbing for building HoloLens developments and get to you to build what you actually want to build. And there's a ton more. I don't want to go through the whole thing. Does anyone have questions on the mixed reality toolkit? Yes.
Do you get updates here, or do you have to import like?
Oh, you have to import it again. Yeah.
Yeah.
It's not that elegant.
It's easy to merge into an existing. You don't have.
Mostly. As you can ask the people that were in my workshop this week. I have a workshop and I tested it a couple of weeks ago, whatever. A week ago, a new version of Unity came out, broke the whole thing, right? So I just went, no, I'm just doing it for the previous version. Too hard.
Yeah,
but
of course, like if you want to pull in new versions of others.
Yeah. So my point is that mostly you just pull it in and be fine. Like they'll extend on APIs, they will just mark them as obsolete, they won't remove anything. Once in a while there's a new version, like there was 10 days ago, that does break shit. Right? And you just gotta deal with it, which is annoying. But that's part of it because we're early adopters, right? So that is the mixed reality toolkit, not the Holo toolkit. Okay. Cool. Next up, we've got gestures. And we talked about gestures because I said there's just tap, right? There's a little bit more than just tap. If you tap and don't let go, it's a hold. You can hold on something. And that's good if you want to, for example, scroll. So you hold on something and then you move your hand, and then that becomes a manipulation, right? When you move your hand in vertical and horizontal. So you got tap, you got hold. You actually got hold start and hold end. You got manipulation in X and Y axis. And then you can also do navigation, which is a 3D kind of, like you had a joystick, you can move things around. So if you tap, hold, and move your hand in 3D space, like in a box, then you can manipulate things as navigation in 3D space. And this is used very often for if you want to move something, you tap on it, hold it, and then you move it over here. You can move a bit closer, a bit further away. That's the manipulation. Sorry, the navigation. So that is still the same tap, right? It's still you got you ready and you press gesture, but you just extend on them to make advanced gestures, I guess. And they're again part of the framework. I'll show you. You don't have to do. You have to do a little bit more because it's a little bit more code. There we go. So I've just picked again another Microsoft example, which is in something called Astroman. And if I can get him running, actually I'll just, yeah, that's the right one. I'll just start him up, see if I can get him running.
Question.
Yes?
How long does it typically take for a first-time user to master those gestures and actually be able to
Good question.
manipulate a 3D model?
So you're talking about someone puts on the HoloLens for the first time,
Yeah.
and how long before they can use it?
Before they understand how
Yeah.
to use their fingers to...
Most people within sort of 10 minutes. Some people will just, they can't coordinate it. Like there's some sort of connection that just doesn't function properly. Nothing wrong with them, it's just, it's not natural for them. You will get all sorts of attempts at tapping, the duck or, the pointing or whatever. But usually people, when that doesn't work and something starts working, you'll start doing that more and more. And it becomes pretty intuitive. It's not a natural gesture initially, but it becomes part of the experience. Move your head. Like you get used to moving like this, right? Oh, there he goes. Because you can always see gestures in front of you. So if you move your head like that, it's not going to tap, right? So these are a bit mechanical like that, moving it. But it takes maybe 10 minutes, 15 minutes usually. My 12-year-old took about 10 seconds. And he just used it. And then the 3-year-old looked at him going, ha! And then walked off. Like it was the most natural thing in the world. So I don't know. We got deployment errors. Okay. So in here, if you were in the first session, you saw the tapped event. It's exactly the same. We have navigation started, navigation updated, navigation completed, and so on. And you just handle these events with your own event handlers and react to them accordingly. So if we say we go to the navigation started event, we just change the position, right? In this case, we're just moving the Astroman dude. It's all really basic stuff like this. Set some position to something else because you know where you're moving. You get that update, which is 60 times a second. You get constant information about where people's hands is, right? That's the navigation updated event. So you always know where they're at, and you can move whatever it is they tapped on or held on. You can move that accordingly. It takes a little bit to get used to, just because if you haven't done Unity before, this idea of 60 times a second you can do something is a bit weird. But you get used to it, and that's how you move things. It feels very resource intensive, but that's how it works. I'll just see if I can get him, if I actually deployed it. Nope. Give me one more go. So again, the tooling in this sometimes just got to restart everything. For some reason, there's artifacts that hang around and it screws up whatever it is. And if it's too slow, like this had to start up the emulator, then the Visual Studio deploy routine times out and stuff like that. That's just part of it. Any questions on the gestures as such? I know you got one, sitting there wanting them.
The toolkit you downloaded, that's open source, is it?
Yes.
Yes. Does it mean that other people in the world are contributing with their own gestures?
No.
No.
No. We do not make our own gestures. I'm just saying, don't. It's a world of hurt, because I said this in the first talk as well. If you do that, not only you have to manage all the raw input and figure out what the hell a gesture is. You got to make sure that that is super accurate, so it works every single time. And then if you get that far without losing your mind, then you have to educate your users on there's another gesture, because they wouldn't know, right? So there's this whole, it just snowballs. So I would never ever do it. Okay, so now we got Astroman. So this is the emulator. I can't make it any bigger because Microsoft. Sorry. And yes, very dramatic. Here's Astroman. It's a little bit loud, hang on. There we go. So Astroman is just another example of using some of these more advanced gestures. So I can, like the cursor is now in the middle, I can move around. As I move off, you can see the cursor changes, which indicates I can do stuff. So for example, if I move down a little bit, here, I can tap and then hold. So I'm just holding down the enter key. So that's now a hold, right? If I then start moving left and right as if I was moving my head, he reacts to that and he starts spinning, right? If you spin him fast enough, he'll throw up in his helmet. No, not really. That would be cool though. But yeah, he spins faster and faster and faster, right? So that's just a reaction to how far you are from where you tapped. And you get all that, you get that in the navigation updated event. And I'll see if I can get, I'll tap on that. Again, more stuff. You get a heads-up display. There's something I didn't touch on the first talk. See, there's this little arrow here. You can do visual indicators, which is very helpful. Because of the field of view is so damn small, any kind of indicator that helps, whether it's audio or visual, that helps the user to go to where you want them is very, very helpful. Very important as well. Okay, so that's Astroman. Whee! I think I can press. Oh, there's the next part of this. This is all a tutorial. The voice command, you can say explode, and he goes. Whoosh. That's not a joke. He can, which is kind of weird. Okay, I'll just shut that up. Okay. Whee. Any more questions on gestures? Yes?
Can you get the position of your fingers in the scene? Or
Not really, no. It's more in relation to where you started, you know, because it needs to know which direction you're going, whether you go forward or backwards. That's a good question. I don't think you can. I'm not sure exactly. They changed this as well. Voice commands. I'm not actually going to show you voice commands. We're going to talk about how you design voice commands, because implementing them, as I showed in the first talk, is really simple. There's hardly anything to it. You just have a keyword recognizer, and then you attach a string, that's your command, and then an action that happens, or an event or whatever. And that's it. Like, you don't have to do anything with the framework. You don't have to do anything manually because the framework handles it all. Yep?
does it work with other languages?
No. No, not yet. There are ways in Unity where you can do others than C# script. I I think there's an F# implementation of some things, but I've never seen anything except C# for.
I was talking.
Oh, languages. Sorry, I had my nerd brain on. You talk. No, it has to be English. I did try with Danish, and put in Danish text strings or whatever, but it just anglified. Like, it doesn't work. So, if you can say the Norwegian word with an English dialect, maybe it'll work. But no, it is all English. Yeah. Okay, so voice commands, really easy to implement, pretty difficult to get right or to get at least obvious. I couldn't actually find a picture of a voice command, so this was the best I could do. I'm sorry. So there's a bunch of rules around speech design that are really important, not just for HoloLens, but in any kind of 3D experience, I guess, or any kind of voice recognition. What actions can be taken through speech? Like, you can do anything with speech that you can do with a tap, but does it make sense? Like, you can trigger stuff that that you might not be able to do otherwise, then it makes sense. If you save a bunch of taps, if you say we're going to have to tap on 6 things and you can just do one voice command instead, that makes sense. If it's not obvious to tap on something, but there's a label or there's a something floating that says, "Hey, say this," make sure it makes sense. Don't just do voice design for everything or voice commands for everything. Is it a good option? It kind of goes hand in hand for completing a task. Like, if you need people to use the hand anyway to tap on something and you have voice in the middle of it, like maybe just not do it. This is important. We talked about this before with gestures as well. How do your users know? Don't just assume that people will know all of the ways that you can interact with your experience. Use something like a little microphone icon that sits over, that hovers over something. Make sure that, if they keep doing the same thing over and over again and there's an easier way to do it with voice, tell them, put up a little speech bubble. Have a wizard of some sort. But you need to educate your users, otherwise how are they going to know? Is the app always listening? By default, the HoloLens has voice recognition turned on the whole time. Right, so if there are scenarios where you don't want it to listen, you need to make sure that you don't react to it, because the framework will just pick it up. What phrases? This is an interesting discussion because, let's say the workshop I did where you shoot a ball on some boxes, we did a voice command to shoot the ball, right? And they're very intuitive that you just, oh, well, let's just shoot. It's easy. But that's actually too short, because we all have different dialects. We all say it in different ways. And if you have a one-syllable word like shoot, it could sound different from different people. But if you get context, so we ended up using shoot ball, if you have context of it, it's much easier for the voice recognition to understand what you're saying. So make sure you don't have these very short commands, because they will probably work most of the time, but you want them to work all the time, right? Interaction dialogue or context. If you ever used Cortana when they first came out, one of the big selling points was that they have contextual interaction. So you could say, "Hey Cortana, what's the temperature today?" And she'd say, "Oh, it's 63 degrees Fahrenheit." Or 60 degrees. And you say, "Oh, can you tell me that in Celsius?" And she'd say in Celsius. Or, "What are the 10 best restaurants around here?" And then she'd tell you, and you go, "Oh, take me to the third one." So this whole contextual interaction, if you want that on here, which is really cool, but you're going to have to build it yourself. Right? You don't get that for free. But it's an important, in some ways it makes sense. You can build up this hierarchy of voice commands, right? But it's tricky, and you don't get any help from the framework, unfortunately. You just get the voice recognition. And then I always put this on, because we forget as developers that we always have network connectivity when we develop. If you have a voice command that triggers a cloud call or something, and you suddenly don't have connection, you got to handle that. Otherwise, the whole thing goes boom, right? That makes sense? Yeah? The design of voice commands is more important than implementing them. It's very easy to implement them. Okay, cool. The next thing is spatial audio. And we touched briefly on this in the first talk. And if you didn't see that, it's really not that difficult. All you need to know is that, okay? There's nothing else to it. So I don't know what that means. It's from Wikipedia. But it is how the head-related transfer function algorithm is calculated. And Head-related transfer function is a binaural algorithm, which means it calculates how sound reaches your two ears. And it's kind of what this diagram is saying, right? If you've got two listening sources, or ears, and you have a sound, as the sound moves, you can see that the distance here is shorter than the distance here, which means that this sound should reach that ear before that ear. That's very simplified, but that's what it does. And that means that when you put it on, and you have spatial audio, these little speakers here are crucial, right? It's super accurate. The framework does all the spatial audio calculation for you. You don't have to worry about any of this mathematics, but it's good to know that that's how it works. All you need to know is that it's there, and we get pretty pictures of it. This is how Microsoft sells it. Yeah, it's got that. Woo! That's it. You know. Audio design is as crucial as it is with voice design. The audio of this, there's a few pitfalls, and I'm not an audio engineer by any stretch, but I've had enough experience now with this that I kind of know what works and what doesn't. You need grounding. You need to have grounding of your 3D objects so they become a natural part of this world. Like, we're trying to trick the user into thinking that they're part of the real world, right? That's the whole idea. So if you can ground your objects with sound, so if you had a bird on the ground, make it chirp a little bit, right, as it's on the ground, or peck on the ground, and it'll sound like it's coming from over there. Make sure you ground them. User attention. We talked about this a little bit before with the visual guidance. If your users don't know where something is, you can use sound to guide them. It's a natural thing. If we hear a loud noise, we turn, right? Everybody does. You can use the same idea with this. If you're, say you're building a zookeeper game and the lion got out, you want to hear that, right? Okay? So use it for user attention. Just like you would with visual, with your gaze, you can have the cursor show you, hey, there's something over there. Turn right, turn right. Immersion, obviously sound is crucial for the immersion of a game. Again, immersion for the HoloLens does not mean lots and lots and lots of sound. It means the right sounds, okay? If you have 100 different elements, you don't want all of them to have sound because it's overwhelming and you won't hear any of them. The same if you have background music, don't, right? I don't know if you were here in the first talk, but there's the background music and it just annoys the crap out of you. Remember, you cannot escape background music. It's on your head, right? You can't run away. So don't use it unless it's absolutely necessary. And if you use it, ground it somewhere so that it sort of emanates from one spot. Interaction design, you can use sound as a way of giving tactile feedback, because we can't touch the holograms as such. But if we click on a button, make it click, okay? That you can use sound for that as well. Gaze mixing is a good way of highlighting objects. So when you put your gaze on something, it highlights and it goes, whoo, or click or whatever it might be. You interact, use the other input methods with the sound. Audio haptics, we just touched on that when you can actually touch on something. Immersion, iterated again. They're crucial for immersion, right? It's the most important thing in HoloLens. In the HoloLens experience is to make sure people are immersed and they believe in it because we're mixing their reality. It's not a VR experience where they know that you've taken away the real world. Okay. Audio. So that was audio. Yes, we will use it in a minute. Oops, sorry. Spatial mapping. That was a bit quick. Spatial mapping. Spatial mapping is what makes or break the HoloLens. You will not have any mixed reality experience if you don't have spatial mapping. It's as simple as that. The spatial mapping comes from these 4 cameras that sits on the front. They map the room you're in and builds up a 3D model that looks something like this. Lots and lots and lots of triangles, polygons. You use spatial mapping in a few different ways. Placement, obviously, if you want to put something on the wall, you need to know where the wall is. You also need to make sure that it sticks to the wall. So your spatial mapping is okay. See if I can explain this right. In virtual reality, you have one 3D coordinate system, right? Because you know where everything is. You made the coordinate system. You made the world in virtual reality. Mixed reality, you don't. You have one coordinate system which is based on your spatial mapping, and then each hologram you place have another spatial coordinate system that is in relation to the overall coordinate system. And you place that using what's called world anchors or spatial anchors. These anchors are in relation to the real world, because you don't always get the spatial mapping correct with the HoloLens. It's not 100% accurate. So something I map over there might, initially say, oh, it's 4 meters away, and I place a hologram there. As I move around the space, it realizes it's actually only 3.8. But if you start moving the hologram, it looks fake, and people lose confidence in what you're doing. So what this does is that you place a spatial anchor with your hologram, and it anchors it to the real world, as in on the 3D model that you're building, right? And then it just updates the distances. Again, crazy hard mathematics that you don't have to worry about, but that's how it works. Occlusion, which is a nice way of saying hiding stuff. You can have characters go behind things, which makes it more believable. So, for example, Young Conker we talked about before, he will jump on your real furniture, go behind your couch, go underneath your table to catch all the coins he needs and whatnot. That's occlusion. Physics, you want stuff to look real. Like when we did the ball before, the little paper ball, you want it to look like it's rolling down properly. You want proper physics. Spatial mapping is used to allow you to have the physics in relation to what the real world is, right? So you want something to fall on a chair and just sort of stop there. You want it to fall through. Navigation, you want characters to be able to navigate your real space. Right? Just like Young Conker can navigate your room. You want people to come in and, if you have characters, they sit on your chairs or whatever it is. So that's what spatial mapping is really, really good for. Now let me show you how it works. This is the cool bit. So, just got to connect everything to my hotspot. Give me a sec, so that I can show you. Turn that on. Come on. There you go. So now I have both my computer and the HoloLens on a local network, which means I can now go here, and I should be able to show you. Make sure that actually runs. Oh, wait. There we go. Oh, okay. All right, bear with me. It lost the connection for it for some reason. Come on, Google. There we go. Then I need to log into it. So what I'm opening now is the developer section of HoloLens. So every single HoloLens comes with these tools. So this is now, I could shut down the HoloLens from the web browser if I wanted to. So the first thing I can do is I can show you if you weren't here in the first session, this is just a bit of fun. And there you go. So now you can see what I see, right? So before we played some stuff, someone got googly eyes. There's a space hat there, space helmet. I think the monkey's still here. Oh, there he is. Hello. Yeah. So there's a few things around the room from the first session, right? What I really wanted to show you is this 3D view. So as you can see, it moves completely in sync with what I'm doing, right? If I move my head, and if I move around the space, it'll actually start moving around as well. So that's, well, neither here nor there. But I can update the spatial mapping, and then it'll show you what has been mapped so far. Let's give it a sec. So there you go. So that's the first sort of row of it. So if I now went over here, don't worry, it won't hurt. All I'm doing now is just forcing the spatial mapping. So just you can see that it works. Come on, there we go. Just to get a little bit more of the room. So we just get a few more than this, the first row. So the range on this is only about 4 or 5 meters, right? So that's why I'd only got the first row when I was standing over here using it. If I update it now, we should get more people. There you go. We can zoom in a little bit as well. Yeah, look at that. More people. And to make it really creepy, we can do first person view. You can see, right? So that's how good the spatial mapping is. You can see it's not super detailed, but it's good enough that you can easily see what's the chair, what's the floor, what's the ceiling, you know, people even. There's no actual method right now to identify people. Okay, we'll just do that again. So that's the model it builds up. You can save this model on your device if you wanted to. I'll just put that there. And you know, games like Fragments will save the spatial room that you're in as the playing area, so you can come back to it. You can also use it for invalidating. You can update it more frequent, use more battery, all that sort of stuff. But that's where you work with, and that's where you place your holograms in. So that's what the device knows, is all of that model that you build up. Yes?
For during development of some sort of experience, can you use that kind of data to just run on your computer, so you don't have to put on?
Yep, it's a very good question. Actually, that deserves Tim Tam, because that was very important. When you develop, you probably won't have. You might have one HoloLens device. You probably, like, unless you're Spatial that I talked to. Was he? No, he left, I think. They have 10 devices. You can take and map a room, and you can import that into the emulator. So you have that room in the emulator. Oh, it's still running. I can show you here. There's some tooling on the side here in the emulator where you can load rooms. Go. Room here. You can load a room. It comes default with 5 rooms. When you install the emulator, you get these 5 rooms. But you can just have your own as well, which means that as a development team, you can all work on the same room, which could be a real room you mapped. So that's a very good question. You can do that. All right. So we don't run out of time again. Go. Okay. So that was. There's a lot more to the developer portal. There's a lot of different tools you can use for testing and for, you know, performance tuning and all that stuff, making sure you don't crash the device. But let's look at testing. And the main thing you'll be doing is what's called environmental testing, because it's, yes, you can write Unity unit tests and you can test your code that way, but testing it on the actual device is really hard. Which is why this comes into it. And there's no, this is a list Microsoft has kind of put out as a guidance, but there's no right or wrong in what you test in terms of environment. It depends on where you expect people to use it. If, for example, the Spatial app, they use that, it's very, very loud, well, you probably don't want to have voice control, right? You don't want to have voice commands. Maybe if you do, you want to test in that environment that they work. But something like light, because we know sunlight is going to screw it up, because sunlight is UV, and that screws up the spatial mapping part of it, which is why it goes really haywire. Mirrors are really interesting because it bounces off. Either they come and they sit out from the wall, or you can just go through them. Mirrors are really hard. Windows don't exist, they're just holes. So there's a few things like that. You need to understand your environment. If you have colored light, what happens if you have a green light or blue light or red light? Like wherever you use it, you might use it in a laboratory where you can't have bright white light, or maybe you can. Sound, ambient noise, as I said before. You really want to test where you're using it if you have voice commands that are crucial for the experience. User movement. It's like user testing on web or any kind of, like, users will do crazy shit, right? They will type in, yes, my name is, you know, Little Bobby Drop Tables or whatever. The same with movement. Users will do all sorts of weird, crazy stuff. So you need to test this really well, make sure that whatever the users do, it's okay. And then physical environment. This is hard because you don't actually know where people are going to use it. Like, you don't know the actual physical environment of what it's going to look like at the time people are using it. But you can have maybe some guesstimates around it. But something, if you were going to place something on the wall, what if the wall is curved? Is it still going to sit there? Is it going to float out? Is it not going to work? Those kind of things that are not natural to us as developers necessarily, because we're used to flat screens and code. But this list is pretty good, and there's the website there that gives you a lot more about environmental testing. One thing I do want to show you is this perception simulation. And this is one way that you can kind of automate what people do, with what a person would do, sorry. And I'll show you how it works. So, of course, you need a slide that says, I'll show you how it works. So, we have this little project here. And I just need the we're going to run it on the emulator, so I just need the network address for it, which is there. Close that. Oh, sorry, I took the wrong one, didn't I? My bad. That one. 94.136. Go. Oh, of course I missed it. There we go. So what this does is it connects to the emulator. This is why I need the IP address. And then you can you create what's called a perception simulation manager. And it's the perception simulation, as in we're simulating how the device is perceiving the 3D world, hence the perception part of it. And we can then use this manager down here and say something like, manager, just pretend you're human, use your right hand to perform a gesture, which is home, so that's the blue. Or head rotate, we rotate our head in some rotation angle. Or we perform a gesture which is finger press, finger release, that's a tap. So all those things you can do, and you can automate this. So I'll just run it up here, start it, and I'll make sure this runs. Give it 1 sec. Building, building, building. Oh wow, still building. There we go. And go. Right, this is the demo gods. There we go. So I'm not touching anything, right? Go, come on. Still not touching anything. I think Visual Studio is running out of resources. There we go. So that's the home, and then we're home again, and then we tap. We see the spatial mapping grid of the emulator. We tap again, then we move the head. I think it is memory, and then we tap, and we bring up the home menu again. There we go. So you can do stuff like that completely as a user would. The cool thing is you can do the exact same thing over and over and over again, right? As a user, you can never do the same thing twice. It's just impossible. But with this, you can. Very easy to set up in your project, which I won't go through because we've got 1 minute left, apparently. Okay. So, okay. Last thing here, which I want to show you, is these. So you could say, well, what's next, right? These are the new devices that are coming out, or one of them. This is still mixed reality, but as you can see, you can't see through it, right? It's more like virtual reality. This is called an MR headset, and this is from Acer. There's some from Lenovo, some from HP, Dell, Samsung, probably a couple others. And it still runs Windows 10. It still runs Windows holographic. Oh, sorry, see, that's the wrong word. Windows mixed reality. They keep changing it. And it comes with, if you've ever done VR, it comes with hand controllers that you probably know. And you can use the same approach through Unity, using like building a HoloLens app, but for these headsets. Now it is slightly different APIs and slightly different development, but that would probably combine over time and be the same. And the idea is that more people would buy these, because these are $400, that's $3,000, but it is tethered, right? But it's kind of cool because it doesn't need any, it's got 2 environmental cameras on the front, so you can still see your room and you still map it, and you can use that spatial mapping inside your app, which is a bit weird because then you can see your room inside the VR, right? But that's kind of the next step. That's where it's headed. So I think a lot more people will buy these than will buy the HoloLens, because $3,000 is just too much. But these, we tried it properly yesterday, because you do need a pretty good computer, which I don't have. You need like a very powerful graphics card to run them, like any other VR device. But it works quite well. It's really convincing, especially the hand controllers. And it's very odd. You can see them in the experience on the table, and you can grab them, even though you can't see them, but you can see them. It's very odd. So that was pretty much all I had. That's me again. I'm Microsoft MVP. They give me stickers and stuff. I still have that on here. Loudest Windows Phone guy in Australia. I'm that guy. I actually have an Android phone now, but that's only 3 weeks old. I have Windows Phone for God knows how many years. I have a website, a blog, if you want to read more about stuff like this and other stuff. And I run a podcast called The Dane and the Pain with a guy I've never met. He lives in Alaska. I've never been to Alaska. But we met through Twitter, and now we have a podcast. Episode 54 is out this week, and it's anything tech. I'm the tech guy. Joel is not. He's a bean counter for a medical facility, and he just likes tech. So it's kind of cool. I thought I'd just spruik it a bit because we don't make any money out of it or anything. It's just good fun. And I do Pluralsight courses. I have one on HoloLens development, of course, which you're welcome to check out. If you don't have a Pluralsight subscription, let me know. I do have some free passes somewhere. And don't forget there's a party tonight. I've been asked to say this again. Music by this very excellent jazz musician that I don't know, but apparently he's very good. But come, 6 o'clock I think it starts. So any other questions before? No? Nothing? No? All right, get out. Thanks, guys.